A cube 1 centimeter on a side is made up of one giant polyethylene molecule having a density of 1.0 gram per centimeter cube. What is the molecular weight of this molecule? Assuming an all-trans conformation, what is the contour length of the chain stretched out? Mer length is 0.254 nanometers. Volume is 1 centimeter cube and density is 1.0 grams per centimeter cube, which means the mass is density times volume, which is 1 gram. So since this is the mass of one molecule, this is the molecular weight. So this answers the first part. Assuming an all-trans conformation, what is the contour length of the chain? So for polyethylene, the all-trans conformation can be written like this. The wedge shows that the hydrogen is coming out of the plane. And so on. To find the contour length, let's see how many mers are there in this polymer chain. So each mer is CH2. It's getting repeated n times. (14 grams per mole) because carbon is 12 and 2 hydrogens is 2. So 14 grams has 6.023 times 10 to the 23 mers because it's 14 grams per mole. So 1 gram will have 6.023 times 10 to the 23 over 14, which is 4.30 times 10 to the 22 mers per gram, and in this case 1 gram is the molecular weight. So contour length is the product of the number of segments of the polymer molecule and its length. So we have 4.30 times 10 to the 22 mers. So we have 4.30 times 10 to the 22 minus 1 segments, because each of this is one segment. So between 3 carbons we have 2 segments. So between 4 carbons we have 3 segments, and so on. Contour length is going to be 4.30 times 10 to the 22 mers times 0.254 nanometer, which is given as the length of 1 mer. So that will be, if you multiply, we get 1.09 times 10 to the 13 meters. So that is the contour length of this giant polyethylene molecule.